Welcome to another edition of ProSoft Technology video training. In this edition, I'll be setting up the MVI 56E mnetc as a client and a server on a ModBus TCP IP network. The MVI 56E ModBus TCP IP multi-client, multi-server communication module for the ControlLogix platform allows Rockwell Automation ControlLogix programmable automation controllers to interface easily with multiple ModBus TCP IP protocol-capable instruments and devices. The mnetc module was created to improve performance on a ModBus TCP IP network by supporting up to 30 clients and 10 servers, with 16 commands for each client. In this video, I'll go over how to import and modify the add-on instruction in RSLogix 5000, set up and configure the module in ProSoft Configuration Builder, and set up some commands. These are the IP addresses for the MVI 56E mnetc module I have in my rack, along with the Ethernet bridge I'll be using. My PC is connected to the rack through a switch. I'll set up the mnetc as a client and configure a read command to a PLC and a write command to a drive on the MB-TCP network, and I'll also go over the mnetc's server functions. So, to begin, you need to decide where the module will reside in your ControlLogix chassis and install it. The MVI 56E mnetc is hot swappable, so this can be done with the PLC powered up. Once you have the module seated in the rack, take note of the slot number that the mnet occupies, as you'll need this info as you go through the setup and configuration process. With the MVI 56E mnetc installed in the ControlLogix chassis, I'll open up RSLogix 5000 to configure the ControlLogix CPU. I can open and edit an existing project or create a new one. I'll create a new project, so I'll define the processor. I have an Allen Bradley 1756 L63 ControlLogix controller. I'll set the revision. And in order to use the add-on instruction, you'll need to use revision 16 or later. Give it a name. Identify the chassis type and select a slot number that the processor occupies in the rack. I have a project folder already set up here where I'm going to save the project files, but the default location will work fine. Once the project is created, I'll expand the I/O configuration in the controller organizer, right-click on the 1756 backplane and select New Module. I'll add my bridge module here, which is a EN2T. So I'll name the EN2T, enter the IP address, and the slot number. And next, I'm going to create another new module. I'm going to filter by Other and choose a generic 1756 module and click Create. In the new module window, enter a name. I'm just going to keep it simple and name it mnetc. I can also add an optional description here. It's important to set the COM format to data int so that the module can communicate over the backplane. The slot number should be the slot the mnet occupies in the rack. The connection parameters should be set as seen here. And these are basically the standard settings for the ControlLogix chassis. If you need to change the RPI, you can do so here. I'm just going to leave it at 5 milliseconds. Next, we'll import the MVI 56E mnetc add-on instruction. You can download a copy of the AOI file by going to our website at www.prosoft-technology.com, or you can get it off the product CD that comes with the module. In the controller organizer window, expand tasks, then main task, and then main program, and double-click on main routine. Once the main routine opens, right-click on rung 0 and select Import Rung. Then browse for and select the mnetc LX5 add-on rung file and click Import. When the import configuration window opens, select controller tags and change the slot number by modifying the local slot number field to match the number of the slot where the MVI 56E mnetc is residing. In this case, I have the module in slot 2 of the rack, so I'll change each field to slot 2. Once this is done, click OK, then return to main routine and delete rung 0. The user-defined data types imported with the add-on rung are now listed in the data types section of the controller organizer tree. So our configuration for the MVI 56E mnetc should be ready to download now. I'll go up to Communication and select Who Active. On the Who Active screen, I'll look in my Ethernet connections and locate the bridge module in the ControlLogix rack. Open up the backplane and select the processor and click Download. Click Download again on the download screen and the CPU will receive the configuration. Once the download is complete, we're given the option to place the controller in remote run mode. I'll do that. And if the option does not come up automatically, you can go over to the controller status bar and be sure that you're online and select run mode. The next task is to configure how the module will communicate with the ModBus TCP IP devices. So to do this, I'll open up PCB with a new project and add the MVI 56E mnetc module to that project. Select the default module in the tree view and right-click to open a shortcut menu. Select Choose Module Type, which opens the Choose Module Type dialog box. Under Product Line Filter, select the MVI 56E, and in the Select Module Type drop-down list, select the MVI 56E mnetc, and then click OK to save your settings and return to the ProSoft Configuration Builder window. You can see that the configuration pane now has a long list of mnetc clients. Now is a good time to save the project and give it a name. The first thing to do is assign the temporary IP address. On the shortcut menu, right-click on the module to choose Diagnostics. This should open the Diagnostics dialog box. If you get back an error saying PCB couldn't connect to the IP address, click the Setup Connection button to browse for the module IP address. On the Connection Setup dialog box, with Ethernet set as the connection type, hit Test Connection to verify that the module is accessible with the current settings. As you can see here, the module's default IP address is 192.168.0.250, and unless your network is on that same subnet, you'll need to assign a temporary IP to connect to the module. Click the Browse Devices button to open up the ProSoft Discovery service. Select the module and then right-click and choose Assign Temporary IP. Choose an unused IP address within your subnet and then click OK. If the temporary IP does not appear in the Ethernet address field automatically, just manually enter it in. Now I can connect to the module. To make changes to the module parameters, click on the plus sign next to the icon to expand module information, then double-click on the icon to open the Edit dialog box. To edit a parameter, select the parameter in the left pane and make your changes in the right pane. Right now, we're looking at module properties. As you can see, the read registers start at address 0, and the write registers start at address 1000. Both have a length of 600 words. We'll need this information when we set up the client commands. Just to be clear, this is only the default configuration. You can edit the read and write data to start wherever you like, for as many words as you like, up to the database's 10,000 word limit. Just take care that your read and write addresses don't overlap. Here is where we can edit the module server functions, and I'll be going over these later. I'll create a couple of client commands, one write command and one read command, each going to a different device on the network. Expand the Client 0 command section and then double click on the icon. This will open the Client Commands editor. To add a command, just click the Add Row button, and to edit the command, double click on the row itself or click the Edit Row button. So first I'll create a write command. I'll set enable to yes. For internal address, I'll set it to 1000 because, as per the module configuration, the write registers start at 1000. I'll leave poll interval at 0, and as you can see, this is the minimum interval between commands that are set to run continuously. And for register count, I'll enter 10. Registers here refer to 16-bit words. No change is needed for swap code. The node IP address is where you would enter the IP address of the device you're addressing the command to. For this example, I'll be sending a write command to the drive on the MB TCP network at 10.1.2.40. Service port should be left at port 502. Slave address can just be left at 1. The ModBus function is where I'll enter my function code. In this case, it'll be 16 to write multiple holding registers. ModBus address in device specifies the starting ModBus register of bit address in the slave to be used by the command. For simplicity's sake, I'm going to set it to 1000 so that it mirrors the address of the module database. And you should know that the function code will add 40,001 to this value in the ModBus device. So the data will show up in the device at address 41,001. There's also a comment section where you can write a comment for your own documentation. Now I'll quickly set up a second command to read holding registers from a PLC. I'll enable the command, leave the internal address at 0 since this is where the read register start is. I'll set the reg count to 10, and that's 10 16-bit words. Node IP will be the IP address of the PLC that I'm addressing the command to. I'll enter a function code of 3 to read holding registers, and the ModBus address I'll set to begin on 0. Again, the function code will add 40,001 to that value, and that should do it. To complete the configuration of the module, I'll set a permanent IP address. The temporary IP will allow us to connect to the module, but whenever the module power cycles, it will be reset to the default IP. The permanent IP address will, however, be permanent. So, go to the Ethernet settings under the module, double-click, and put in the IP address that your network administrator gives you. In order for the module to use the settings that I've just configured, I must download the updated project file from my PC to the module. In the tree view, right-click on the MVI56E mnetc module and select Download from PC to Device. This opens the Download dialog box. Select Ethernet as the connection type, and notice that the Ethernet address field contains the temporary IP address that I assigned in the previous step. ProSoft Configuration Builder will use the temporary IP address to connect to and configure the module. Once the module reboots, it will begin using the permanent IP address. Click Test Connection to verify that the temporary IP address is working. If the connection succeeds, click Download to transfer the Ethernet configuration to the module. The module will reboot using the new configuration. As an alternative to connecting to the mnetc through Ethernet, you can also use SIP Connect. This method uses the 1756 Ethernet bridge in the local rack to communicate with the module over the backplane. This could be handy if you can't connect to the mnetc module directly. For instance, if your Ethernet IP network is not on the same subnet as your ModBus TCP network. To use SIP Connect, on the download window, choose 1756 ENBT as the connection type. The default path will appear in the SIP Connect field. Click the SIP Path Edit button to open the SIP Connect Path Editor dialog box. Here you can define the path between the PC and the MVI56E mnetc module. The source connection will always be a 1756 ENBT module. If the mnetc is located in the same rack as the NBT module, then this is all you'll need. If the mnetc is in a remote rack, then you would include that rack as well using the Add Rack button. Once I enter the IP for the bridge module and specify the slot number of the mnetc module, I'll just click on Construct SIP Path to build the path in text format, and then click OK to confirm the new path. Then back on the download window, click Test Connection to verify that SIP path is available. You'll get a message telling you if it was successful. Click Download to download the configuration to the module through the SIP path. At this point, the client configuration for the MVI56E mnetc module is complete. So I'm going to go back to RSLogix 5000 and open up the controller tags. I have a tag here called mnetc. This is the name that I gave to the module when I created the project in RSLogix. It's not the default name for the tag. So this will actually be whatever name you gave to the MVI56E mnetc module in RSLogix. Under mnetc, expand mnetc.data and then expand read data. The data from the read command that we addressed to 10.1.2.50 will appear here in mnetc.data read data 0 through read data 9. Because we specified a register count of 10 words. So, staying in RSLogix, I'll expand mnet.data write data and enter some values between write data 0 and write data 9. The write command will write these values into the drive at address 10.1.2.40, and they'll appear in the drive at Modbus address 41001 through 41010. And that does it for the client commands. Another feature to point out is the ability to enable or disable commands from here in the controller tags. A disabled command has its bit in the mnetc control.command control write command bits controller tag set to 0. It will be skipped during routine polling. An enabled command has its controller tag set to 1 and is sent during routine polling. The state of these write command bits overrides whatever value is assigned in the enable parameter in the configuration. By default, the first two commands for client 0 through client 9 are all enabled and all other commands are disabled. If your application requires more commands, you'll have to be sure to go in and edit these tags to enable the commands. Keep this in mind. Now back in PCB, I'll go over the MNet server properties. As you can see, this is mostly database offset information that will be used by the module when accessed by external clients, such as SCADA systems or HMI stations. These offsets can be utilized to segment the database by data type. The offset address corresponds to the address in the module's internal database. So any value over 0 will enable these, otherwise there will be no offset. One thing to note is the float start and float offset only kick in if float flag is enabled. For the vast majority of applications, this would not need to be enabled. You do not need this in order to send float information. It's only for very specific cases. Now, the reason you might use an offset is that different data types, such as input registers and holding registers, have different ModBus addresses in most ModBus devices. But in the mnetc, they'd be written to the same address in the database. So an offset to one or the other is necessary to ensure that no data is overwritten. For the tutorial, I'm going to go to holding register offset and enter a value of 50. So any external ModBus clients that want to write or read holding registers from the mnet will read from 40,001 and write to 41,001, but actually be accessing database address 50 in read data and write data in the module. So I'm going to download this to the module now, and you'll notice that I'm using the permanent IP address now. Now I'll go back to RSLogix, and I'll open up mnetc.data read data, and I'll look under address 50. This is where the data being read from the client device will appear. We set an offset of 50 in ProSoft Configuration Builder, and so even though the client is writing to address 0, it's actually coming in to address 50 in the mnetc database. And we'll take a look at the write data while we're here. Just open up the write data and again go down to address 50. And here you can enter some values, and this data would be written starting at address 41,001 in the client device. And that should do it for this training session. If you have any questions about the configuration process in PCB, the user manual for the MVI 56E mnetc goes into great detail on the settings and options available for the module. You can also visit our website or give us a call. Happy training!